Hey everyone, welcome back to the voting system tutorial. In the previous episode, we took a look at how to abstract our problem into reusable components, and we ended up with a counter manager and the counter manager manages the counts and everything relating to that. And we ended up with this neat solution where we can add as many counters as possible, and that would add up to some amount of votes, right? In this episode, we're going to take a look at some testing frameworks or libraries that we can use, primarily xUnit and Moq. And for this, I'm going to go ahead and add a new project. So let's go ahead and add a new project. I'm going to go ahead and look for test. And here I want to select xUnit test project.NET Core. I want to make sure that C# is selected, and let's go ahead and click next. And here I'm just going to go ahead and type in voting system .test, right? So usually you'd have a library, and the tests for the library that you have, you just prefix it with .test. So if you have a module of like .core, the tests for that module would be ending with test or tests, right? So let's delete the core, and we're gonna have voting systems.test project. Let's go ahead and create it. Okay, so here we have our sample unit test. Let's go ahead into the project. And first of all, we'll check out the CS proj to see what we get here and quickly dissect the packages. So Microsoft.NET Test SDK, this is what is needed to run the tests. xUnit is the library. xUnit runner.visual studio is the package to be able to run these tests within Visual Studio. So if in the search window up here, we search for test and look up at Test Explorer, and if essentially you don't have any tests showing up here, that means you're missing this package here. Coverlet.collection is a package for code coverage that your unit tests are covering, but we're not going to be focusing on the code coverage since there's much better tools out there like .cover, which can be installed for free with a trial, but mostly they work for quite a long time. So if you want a code coverage, I recommend check out .cover, and I'll leave a link for that in the description. So the basics of unit testing. Let's go ahead and create a class that we want to test. And this is not an example of TDD. This is just going to be covering some functionality that xUnit provides, right? So let's create a public, and let's actually make a static class. Or do we need? No, we don't need it. Let's just call it test1, and then here we'll make a function called add. So public static, it will return an int. Add, it will take two integers, a and b, and it will add the two together and return that. So there's primarily two attributes, well, a third one in a second, that you want to know, and that is, the first one is fact, and it is what it is. So the creators of xUnit, what their aim was is to create code that is self-documenting. So this is how you essentially want to do it. You want to pick a style in which you're going to name your tests. So for example, if this class would be called, let's say, test1 tests, right? It's already implied that these tests are for test1, and here we're going to say that adds two numbers together, right? So this is what you would expect from this function, and let's go ahead and test this. So we would have the result, and for this test, our result would be, let's say, or I guess wait, hold up, test1. First, we want a addition of something, so let's add 1 and 1, and this would be 2. So the next thing is you want to know about the class assert, and this is a collection of static functions, and essentially these functions are meant to compare or enforce a rule, right? So here we're saying that the result should be equal to something, right? So 1 plus 1 should be equal to 2, right? So what we're going to do is put 2 and result, and xUnit should be very friendly in terms of where you put stuff in as parameters. So if we would change them around this way, you should get a green underline, and this is essentially the fact that you want to swap arguments, because if we peer into the method, you essentially have the expected argument and then you have the actual argument, right? So expected is what you expect to get. Now, this is essentially like one of the simplest tests you can write. Let's go ahead and introduce a theory. So we are going to copy this test here, and let's go ahead and name it theory. Usually you would have only one version of this test, so this would be the theory that we're about to write. So a fact is no parameters, you're just whatever's contained in the body, that's going to get executed, all good. Let's go ahead and replace this with a theory. And what the theory does is essentially it will expect parameters in your function here, and you want to be able to pass parameters into this function, and depending on many different scenarios, you want to test that. And the way you supply parameters, to begin with, you want to actually add them here, and let's also say result on the end. So we want the A, the B, and the thing that we expect. So we can actually rename this to expected. Now let's supply these parameters in this function, and let's say expected. Okay, and now we want to provide inline data, and this would be 1, 1, and 2. These parameters would have to match the parameters that you have here, right? So now what you can do is you can test multiple outcomes, like what would happen here. And I guess the most important part, how do you run these tests? Again, the test explorer you find here, and again, if you don't have it, you go in here and you make sure you have xUnit runner.visual studio package. Just press the green button, and then that should build your solution and your project and execute these tests, and hopefully they all pass, right? So there they are. You will notice that for the fact there is no drop down here, it just adds the two numbers together. For the theory, you will get 3 individual tests for each one of the theories, and if one of them fails, you will be able to see here, and the exception will happen here. So let's go ahead and take a look at what will happen if a test fails, right? So let's go ahead and build it. Let's first take a look at what happens on the left here, and you will see that 1 is now turned to a blue question mark, and this is essentially, since last time you run, all of these tests pass, but this test has changed, so we don't know if it's going to pass or not. So let's go ahead and rerun this single test, since we know the other tests haven't been affected, and it breaks. And this is in terms of the message that you're going to get. So you can see the assert that has failed, you can see what you expected and what you got, and at this point you would go to the source of the unit test that will happen, and you try to find out what has gone wrong. You're like, alright, so this is actually meant to be 1, and you fix it. So now let's explore a few more options of this assert function. Let's go ahead and just make it public void test list contains value. This is what we're going to test, and we are going to say fact. And let's go ahead and create a list of some sort, and this is going to be a new list. I'm just going to make integers because why not? And let's say 2, 3, and 5. All right. And just to give you a broader idea of what kind of functions this assert contains, like equals, true, not null. So not null is if you would have been checking that the value that you're going to provide is not null. False, so these are Boolean values, and the things that you don't want to do is, for example, true. We would say something like list contains 1. Okay, and again, xUnit will be very friendly in terms of reminding you how you should write it, because assert will already have a contains overload, right, or not contains. So you don't want to do these sort of calls. You generally don't want to use function calls within these unless you specifically have to. But when it will basically correct you when there is an easier option. Otherwise, do what you have to do to write the test. Okay. And again, to check collections, to check values, compare objects, etc. Remember that you expect whatever you expect, you put it on the left, and what you got, you put on the right, and this compares. So as long as this assertion doesn't fail, your tests pass, and this helps you to sort of make sure as you change the code over time that it doesn't break. Okay, and this is the primary motivation behind unit testing. Okay, so let's go ahead and run all our tests, and hopefully they will all pass. Oh, I just ran the one test. Okay, and again. Okay, all right, programmers now. Nice. So another thing that will happen is you will have interfaces in your programs, right? So if you worked with .NET Core 3 and you injected your repositories into other classes, controllers, whatever, you have interfaces. And generally, if you're beginner level, you don't really know why interfaces exist or why to use them. But hopefully today I can sort of show you why they're there, okay? So let's say that this test 1, let's remove the static function here. And for all of these, we will just say new to fix our tests. Okay, so this would implement the interface, and not a class, sorry, interface, I test 1. And we would have an integer add int a, int b. Okay, and this is an implementation of I test 1. And let's put the interface a little bit slightly above. So what's the deal with interfaces and how could we use them? For this, I would actually like to create another class, and let's go ahead and create a public class, and we'll call it something like math1. Okay, and in this math1, we'll create a constructor. So we're going to be passing something in here, and exactly we're going to be passing this interface here, and we'll just call it test1. And let's create a field for this. And all we're going to do is we're going to create a public int add int a and int b. So really simple. We're not really adding any usefulness here. We're just going to sort of replicate what has happened. But imagine that we could take multiple interfaces here. But the point of this will be that this math1 can be tested separately from test1. So math1 tested separately from test1. So test1 tests are going to be testing test1 class. The interface, you don't test the interface. You program against the interface. Okay? So here we don't actually have an implementation for it, right? Imagine test1 doesn't exist, right? We just have the interface. And then later on, whatever is going to implement iTest1, we can pass it on to here. But essentially, the way that you write a test for math1 without an implementation for the interface is using a Moq library. So let's go ahead and create a public class math1 tests. And these would be in different files, but for this example, I think it's okay to have it in here. So usually you'd spread it out, but for now it will be all right. So here, let's go ahead and say public, and let's actually start with a fact, right? So it's going to be a fact void math1 adds 2 numbers. Okay, so how can we check that it adds 2 numbers? The only way that we can really check if we provide an implementation in this solution. So let's go ahead and create a test1 equals new test1, a var math1 equals new math1, and now we can pass test1 in the constructor. And what we will do now is assert equal, and we'll say 2 because what we're going to do is math1 add 1 and 1. Okay, so really simple. We're going to run the tests again and they will pass. But hopefully you will see the problem that the tests for math1 test start to depend on test1 just because we surfaced this class here. to be passed as an implementation for this interface. So right now, our math1 class is tightly coupled to test1 because our tests depend on test1 existing. If test1 stops existing, all of our tests start failing. We need to implement or program against the itest1 interface. So how do we do that? This is why the MoQ library exists, and we'll show you how that works in a second. We're going to right click on our project and we're going to go to manage NuGet packages. We're going to search for MoQ, and we're going to search that in the browse field, and we're going to get the MoQ library. Let's go ahead and install that. Once that's installed, let's go ahead back into our project here, and we're going to delete the test1 here. And what we're going to create instead is a test1 Moq, and we will create a new Moq class, and we will import MoQ. So we're going to using MoQ at the top here, and we're importing this library, and this is where this class comes from. Now, this class is going to be a type of, right? So it's generic and it has a type, and the type is going to be the interface that we're going to pass. Okay, so test1 Moq, what the Moq and MoQ library allow us to do is to set it up so we can, in this test, we can provide the return values that this function is going to return, the add function within this interface. Okay, so what we essentially say is, right, if test1, if the interface, no matter the implementation, if it returns certain values, this is how our math1 class will behave. Okay, so our math1 in the implementation, it depends on the itest interface. Our tests need to mock out the itest1 interface. Okay, so let's go ahead and set it up. Test1 Moq, we call the setup function, and in this function we provide a function which will allow us to select a function. So a lot of functions here, don't get lost. One function and then a lambda function to select a function or a property. You can go as far as, let's go ahead and test1 Moq setup property, right? So you can set up properties. So if you have properties like, I don't know, name, whatever, you can set those up. We're not going to do that here, so we're going to go simple. Let's say that if we call this with the arguments of 1 and 1, this function is going to return 2. Okay, so what we're doing is we're specifying the behavior of the itest1 interface. And now what we want to do is we want to pass in the interface to our math1 implementation or constructor. And we do this by extracting the object from the Moq object. All right, so this is going to be type of itest1. So now when this runs, what's going to happen is we're going to set up a Moq of type itest1. We're going to say that the add function is going to return 2. And when this runs, there is no concrete implementation like test1. And now all we're doing is we're mocking the behavior of the interface. I'm hoping this is getting through. We're mocking the behavior of the interface. Okay, there is no implementation for it. There is certain behavior that's going to happen, and then we're going to test the outcome based on that behavior. And this is a super simple example, and it's completely useless in this scenario, but it's primarily for learning. Okay, nobody writes tests like this, and once we get to writing tests in the next episode, we will actually see how this works and why it works and why this exists. Okay, but let's go ahead and run this. And our tests pass. Okay, and if we would have said something like 2 here, let's go ahead and run this test again. You can see that we actually get 0 because we have never set up anything, so the default value is returned. So the default value for an integer is 0. Okay, so let's go ahead and change this back. And sometimes what happens is functions are void. So let's go ahead and make a public void out or something, right? and this would have to implement this now, and we'll say system.system, too much Java, console.writeLine, hello, right? So this doesn't return anything, okay? So what happens? Like how do we test this, right? And let's say we do the same thing here. We're gonna make a out, and we're gonna call out here. So how do we know that this works? And sorry, this must be void as well. How do we know that this works? How do we know that this function has been called? Because you know it doesn't return anything. We can't check against the return value. Well, this is where the mock library has got you. It's got you back, all right? And it's going to allow you to check if a function has been called. So here we're just going to say that verify function has been called, okay? So again, we're going to create a test1 mock, but this time the setup, we're not going to have it. We're just going to pass the object of the interface. And now instead of assert, we're going to be using the test1 mock, and we're going to verify on it. And verify is a function where we can again select a function like out, okay, and we can verify that it's been called, okay. And let's look at the overloads, because again you can basically provide how many times the function has been called, right? So you can expect the function to be called certain times. I'm expecting it to be called only once, and you don't really provide a number here. What you need to do is you need to provide the times class, and here you specify once, never, exactly, and if you specify exactly, then you need to basically specify a number. But otherwise you use the convenient method once, right? So you verify that this has been called once. Let's go ahead and run this test, and it fails because we haven't actually called it. So let's go ahead into math1 and let's call out here, and now that we're calling it, let's go ahead and run it again, and it passes, right? Because now when we call this function calls this test, and sometimes this is very useful just in case you want to know that the exact parameters have been passed. So let's say this will accept a string of message, and again we'll have to change this to message, and now we're going to be supplying a message to the console. And here as well, we're going to pass a message, and we're going to pass a message down to this function. And here we're going to say hello. And here we want to make sure that it's been called with the hello message. By the way, in the future when you're going to program, you're going to be caught out with like object references. So a good idea is always, whenever you're dealing with parameters, to avoid like let's pass message here. Let me finish typing before I start talking again. So we're gonna get the value here and pass it here. Okay, so if this is an object, it's gonna have a reference, and then if you create two new objects, for example, like this, and another object here, right? Even though they're the same right now, they're essentially different because they are different references in memory. So comparing values, unless you override the equality compare, but again, I'm trailing off a little bit, but essentially the stuff that you're comparing, you want to assign it to a variable so you know that you're getting the singular instance. So let's keep this here. So we're passing a hello here, and we're expecting an out to be called with this message. Let's go ahead and run this, and this should pass, and then we'll change the message parameter to something else, like blah. If this is called with something else now, essentially it will fail, right? So if you have a service that saves something to the database based on the parameters that you pass, you can say, right, I'm going to pass you my name, my surname, my age. I want you to store the full name and the age in the database, and if not, the correct parameters have been passed to something like database context.savechanges, then you know your test will catch that, and you know your program doesn't work and you will have to fix that. But essentially, let's go ahead and change this back to a message. And this is all there is to testing. So to quickly run down, you have a fact to check a singular thing. So remember to keep your names consistent. Choose a pattern in which you want to specify your rules. So for example, maybe a method function name and what happens based on something. That's the general pattern I go for, usually to separate the method and the meaning behind there. I use underscore. Some people don't. I tend to do that. And then you have theory. So if you want to test with more than one parameters, you're free to do so by using theory and inline data. And whoop, inline data supplies parameters in the same order as you defined your test function. And then you have your Moq library, which is essentially allowing you to program against interfaces, right? So you can have many things that implement this interface, and those tests will be for those implementations. And then once it comes to the thing that is going to use the interface, you don't want to supply these implementations to that interface. You want to use Moq to simulate some sort of things happening and verify that some things have happened to that interface when they were used in this class. Okay, so this is how you make your tests decoupled. So your math1 tests don't depend on your test1 tests or the test1 class. So the modules are per so. Test1 tests are with test1, and math tests are with math1. Okay, and for Moq, all you do is you either set up a function to return a certain value with a certain parameters, as you would usually expect it to be called by the function of the class you're testing, or you verify that a specific function has been called with the specific parameters a certain amount of times. And that's all there is to the syntax of these two libraries. Of course, test-driven development and writing tests for bigger system gets complicated very quickly, and organizational skills, just like in real solutions, matters in your test projects as well. Otherwise, tests stop working and you stop relying on them and you stop seeing any benefit in writing them, okay? But this will be it for this episode. Thanks for watching. If you enjoyed it, leave a like, subscribe. If you have any questions, make sure to leave them in the comments. I know testing can be a hard topic to grasp at start, but as soon as you start writing tests, off you pop. You're going to have a good time. Don't forget to join the Discord server. And as always, see you in my other episodes.